Hello everyone, good morning. So today we will understand some more concepts related to chapter 5, that is special types of quadrilateral. As you have already understand about what exactly special types of quadrilateral is, what are the different properties of special types of quadrilaterals and how they are different from each other. So today we will understand the new concept, that is concepts of parallel lines, right? How parallel lines are making difference in solving questions, and one more concept related to Pythagoras theorem, right? So today we will understand all such things clubbed together. So without wasting any further time, let's start. So the concept of parallel lines, as I have already discussed with you what exactly parallel line is, so let me just revise one more time. Parallel line means what? The two lines, a pair of lines which have same distance in every sort of points, right? The gap between two lines, if they are same in every possible points counted, then we can say that this pair of lines are called parallel lines, right? So now there is one more concept related to parallel lines. Now see, this is one parallel line, and now when one line, the new line will be introduced over here, that new line will be this one. This line is called as transversal. This line is called as transversal. Let me just write this name, transversal. Transversal is nothing but that line which intersect the parallel lines in 2 points, right? In 2 points. It could be same point or it could be different point. Same or different means, if it is straight, then we can say that the two lines, the points will be like aligned with each other, and if they are cutting like this way, inclined way, then we can say that these 2 points are not aligned to each other. That's it, right? But when this line called as transversal, when the lines are parallel, when the lines are parallel, then the another line, when it is getting intersected with the parallel lines in 2 different points, then we can say that this particular line is a transversal. So what is the significance of transversal? How transversal is making difference in parallel lines, right? So let me just give you some more data related to it. Now see here, how many gaps are you are actually watching? How many gaps are there? Let me just tell you. See, there are 1 gap, 2 gap, 3 gap, 4 gap, 5 gap, 6 gap, 7 gap, 8 gap. So what is that gap called? Angles. You know that. What is that gap called? Angles. Now let me just give one name for you. That is 1, 2, 3, 4, 5, 6, 7, 8. So how many angles are there? There are 2, not 8 angles are there, right? Now let me just discuss one-on-one concepts with you. Now see, the first 2 concepts, it does not make any resonance to parallel lines. It will eventually occur if the lines are not parallel also, right? So what are that things? This line is, one line is there and there is another line. So that is not transversal because there is the missing of one line which is parallel to that above line. So that is, this line is not transversal. But you just see, it will occur how many angles? 4 angles are there. Let's say 10, 11, 12, 13, right? Right? So if you just see that in this point, when it intersect at this point, there it is creating 2 angles, and if you just put the protector over here, you will see the total angle is how much? The total angle is 180 degree in total. In total, the measurement is 180 degree in total if you just put one protector over this line. So by observation we can easily understand that this gap, that one gap plus another gap, it is actually creating 180 degree. So angle 10 plus angle 11 equal to how much? That is 180 degree. Like that way, if you see in the downward side, that angle 12 plus angle 13 equal to how much? It is 180 degree. And this concept is nothing but called as linear pair. This concept is nothing but known as linear pair. Is it okay? Linear pair. Now see, this is the first concept, that is linear pair, which does not take any resonance or any significance whether the lines are parallel or not. It will be same if the lines are parallel and if it is not, right? So the next concept is that this gap is actually equal to this gap. How? That will be the question, right? Why this gap is equal to this gap? Now see, if I make one line again, this is the line, right? So here the angle is how much? 11 and 10. So if you just see over here, this is 11 and this is 10, and if you just rotate this line like that way, if you just rotate this line like that way, you will get to observe that, just pick it up and rotate it. Just pick it up and rotate it. Half rotation, not full. Half rotation. So the scenario will look like exactly look like 13, 11, 10 and 12. So if you see at this position, before rotation, at this position, what is that angle? That is angle 10. But after rotation of 180 degree, because it is half rotation, no? If it will be a full rotation, that it will be 360 degree, right? Complete rotation. But since I have told you to do the half rotation, then we can able to see that this is angle 10 at this position. After rotation, that will be angle 12. Same figure, right? Same figure, no? So that means this angle, that is angle 10 and angle 12 are absolutely same. These two angles are absolutely same. That is angle 10 is equal to angle 12, and like that way angle 13 is equal to angle 11. Angle 13 is equal to angle 11, and that property, that specific property, is called as vertically opposite angles. That concept is nothing but vertically opposite angles. I highly recommend you to write these concepts in your copy while watching it, right? Because if you just watch this video, then you will get nothing out of it. You need something to write down. So make sure you just open up your copy and write it down along with me, right? So that your concepts are getting much more crisper. So these two concepts, that is these two properties, gets nothing resemblance with parallel lines. It will occur if the lines are not parallel. It will occur if the lines are parallel, nothing else, right? So like that way, in this figure, can you now able to tell me that which angle is equal to which angle on vertically opposite, using vertically opposite angle? Easily we can tell that. That is angle 2 is equal to angle 3, angle 2 is equal to angle 3, angle 1 is equal to angle 4, angle 6 is equal to angle 7, and angle 5 is equal to angle 8 by which property? That is vertically opposite angle, right? Vertically opposite angle. So right now I think that the concept of linear pair and vertically opposite angle is clear to you. So now linear pair, in case of linear pair, you just see how many linear pairs can we actually frame out. Angle 1 plus angle 2, angle 1 plus angle 2, that is also 180 degree. Angle 3 plus angle 4, that is also 180 degree. Angle 5 plus angle 6, that is also 180 degree. And angle 7 plus angle 8, that is also 180 degree. And what is that property? That is linear pair. I think now linear pair and vertically opposite angle, these two concepts or these two properties are absolutely clear to you. So after that I will tell you some more properties related to which will actually occur only if there is parallel line and nothing else, right? So let's just do one. Let's just actually understand that concepts. After the two properties, let's just understand the three more properties which are much more essential for you to understand, right? So the first property is called as alternate interior as well as exterior angle property. So what is that? Interior means in the middle portion. So how many angles are there? There is 1, 2, 3, 4. 4 angles are there. So alternate interior angle actually saying that the two crossover angles, they are absolutely equal with each other. So that means the cross angles are nothing but angle 4, that is equal to angle 5, and angle 3 is equal to angle 6. So that is coming under alternate interior angle. Alternate interior angle. So now let's just understand what are the alternate exterior angle. So that will be the exterior parts. So how many angles are there? That is 1, 2, 3 and 4, right? 4 angles are there. So that means crossover 2 and 7, angle 2 equal to angle 7, and then angle 1 equal to angle 8. So same, that is alternate exterior angle. Alternate exterior angle. Understood, right? So now let's just understand the next property. That is after that there is fourth property. Fourth property is corresponding angle. Fourth property is corresponding angle property. So what is that basically? Basically means this star angle. Now see, in alternate angles, which angle is equal to which angle? Angle 4 equal to angle 5. Let's just straight jump into angle 4 equal to angle 5, right? Angle 4 equal to angle 5. So now see, angle 4 is equal to angle 5. We have angle 4 equal to angle 5, and that angle 4 is actually equal to angle 1. Why? Because vertically opposite angle. So that is coming under alternate interior. Alternate interior. I'm just taking that short form, but you have to write it down briefly, right? Like this way. Alternate interior angle. I'm actually writing it to reduce the time, nothing else, right? So the video length will be shorter. Now angle 4 is equal to angle 1. Angle 4 is equal to angle 1. That is vertically opposite angle, right? So now see here, angle 4 and angle 4. Angle 4 equal to angle 5, angle 4 equal to angle 1. So that means angle 1 implies angle 1 equal to angle 5. So that angle 1 actually that is equal to angle 5. Angle 1 is equal to basically angle 5. So that property is nothing else called as the new property, that is called as corresponding angle. corresponding angle. And the same process will repeat on to the rest of the angles. So let's say angle 4, angle 2, that is equal to angle 6, angle 2, that is equal to angle 6, angle 2, that is equal to angle 6, and then which one remains? Angle 4, that is equal to angle 8, and angle 3, that is equal to angle 7. No need to write this one. Angle 4 equal to angle 8 and angle 3 equal to angle 7, and both the three cases are actually occurring because of corresponding angle, right? That is the fourth property. And last we have one more property for you, that is called as co-interior angle. So now let's just understand the fifth property, that is co-interior angle. Co-interior angle property. Co-interior angle property. So now in co-interior angle, now just see, angle 3 is equal, angle 3 plus angle 4, angle 3 plus angle 4 gives you what? That is gives you 180 degree. We know that is linear pair. Linear pair. And like that way, angle 6 plus angle 5, angle 6 plus angle 5, that is actually 180 degree, which is actually the same reason, that is linear pair. Linear pair. Now if you just see, if I just add these two numbers, what we get? Angle 3 plus angle 4 plus angle 6 plus angle 5, that gives us 360 degree, right? So now in 360 degree, what we have to do? Now that is the case, that is the main cause. After that, what we have to do? You just see, angle 4 is equal to angle 5. We know that angle 4 is equal to angle 5 by which property? That is alternate interior angle. So angle 4 plus angle 5 is equal with each other, and angle 3 is and angle 6, these two are equal to with these two are equal, right? So we can write like twice angle 4, or for instance, I just repeat this term, angle 3 we can write like angle 6, because angle 3 and angle 6 both are same, and then angle 4 plus angle 6 as it is, and angle 5 we can replace angle 5 by angle 4. Why I am writing this? Because angle 4 is equal to angle 5 and angle 3 is equal to angle 6 by which property? That is alternate interior angle. Alternate interior angle, right? We can write like this. So now if you just see angle 6 plus angle 6 and angle 4 plus angle 4, so that means twice angle 6 plus twice angle 4 equal to 360 degree, right? So we can take twice as common. Angle 6 plus angle 4 equal to 360 degree. So after that, what we can do? We can write 360 degree as angle 6 plus angle 4 equal to 180 degree into 2, right? So now see, if you just see that that's actually the which part it is this is actually the equivalent fraction. So we can do like 2 by 3, let's say. So what is the equivalent fraction of 2 by 3? That is 4 by 6. So what we just did, 2 into 2 and 3 into 2. So if I just remove this 2 and 2 over here, we can get the original answer. So like that way, here 2 and 2 both are getting multiplied. So if I just reduct this 2 and 2, what we get? Angle 4 plus angle 6 equal to 180 degree, right? So finally we can get angle 4 plus angle 6 equal to 180 degree, and that is the new property that we know as co-interior angle. Co-interior angle, and the same process will repeat for 3 and 5 as well. So for 3 and 5, angle 3 plus angle 5 equal to 180 degree, that is actually co-interior angle. Co-interior angle, right? Co-interior angle. And for outside, that is angle 2 plus angle 8, that will be co-exterior angle. Simple, because interior there are 4 angles are there, and in exterior there are another 4 angles are there. So for 2 and 8, for angle 2 plus angle 8, that is also equal to 180 degree, and it will be like co-exterior angle, co-exterior angle. And the same process will repeat for 1 and 7, that is angle 1 plus angle 7 equal to 180 degree, and that is also co-exterior angle and nothing else. So that's all for the concept of parallel lines. And one more, I hope now it is clear to you, right? If you found something doubt related to this concepts of parallel lines, I highly recommend you to watch this video from the beginning as well, right? And then after that, if you are still getting some doubt, do contact me directly. There is no such problem to contact me, right? I'm there for you to help you out, right? So let's just move on to our next concept, that is Pythagoras theorem. So now let's just move on to our next concept, that is the concept of Pythagoras. So now let's just move on to our next concept, that is the concept of Pythagoras theorem, right? In Pythagoras theorem, what is this? Basically, Pythagoras is no one but a great scientist, right, who has discovered or invented many sort of things. Like the biggest achievement of his career was Pythagoras theorem. So what is that actually? Pythagoras theorem is actually available on triangle. So what is that? In triangle, there must be how many types of triangles? There are numerous types of triangles are there, right? But we are continuously focusing on one specific types of triangle, that is called as right angle triangle. So what is the fundamental of right angle triangle? In right angle triangle, there is one speciality, that is one angle, it should be 90 degree, right? That is the speciality of right angle triangle. If you see, this is the triangle of ABC, and at angle B there is 90 degree. So in Pythagoras theorem, what exactly Pythagoras was eager to tell you that 90 degree, whenever there is 90 degree, so that means it will be the largest angle among all these two angles. How? Because the total sum of this polygon is 180 degree, and if one angle holds 90 degrees, so definitely the other two angle, it will be clubbed together to become 90 degrees. So that means individually it will be less than 90 degree. We understand that, right? So that means at this position the angle is 90 degrees. So what exactly he told, that the angle which is the largest and the opposite side will be the largest side. The angle which is the largest and just before and just opposites, whatever the side is, it will be the largest side. And there is the specific name for this side, that is called as hypotenuse. That is called as hypotenuse, or which is written by H, So if you see, 90 degree is the largest angle, and the opposite side is this side, that is AC, which is called as hypotenuse. And there is a ground part, if you see, if you just visible, if this triangle is visible from this side, but if you just stay over there and saw this triangle, you just see that this triangle will be from this side, right? So at this point we can say that this is the base where the triangle is situated. But when we are watching from this side, we can say that AB will be the base. So no matter what you are taking, right? So no matter what you are taking, but basically there must be one base which is called as this part, base, or you can represent this as by B, and there must be one perpendicular. So what do you mean by perpendicular? Perpendicular means where there is one 90 degree which is dropping out there. When one side or one line is dropping in such a way to the base such that it creates 90 degree amongst the base, so that means this line is called as perpendicular. What I just say, when a line is dropping towards the base in such a way that it creates 90 degree, the gap should be 90 degree, then we can say that this line is called as perpendicular line. So AB is nothing but perpendicular, but because it creates 90 degree towards the base, so that means this is perpendicular, or you can simply write it down as P. So according to Pythagoras theorem, his formula is nothing but hypotenuse square, that is equal to base square plus perpendicular square. So that is the formula. Hypotenuse square is nothing but equal to base square plus perpendicular square. If you want to check it out, then let's say 3, 4, 5. So amongst these 5 is the largest side. So that means H is 5, or let's say 5 centimeter. P is 3 centimeter, and B is, let's say, 4 centimeter. So according to Pythagoras theorem, H square is equal to 25, B square is equal to 16, and then P square is equal to 9. So that means P square, B square plus P square, if I just did 16 plus 9, which gives us 25, that is equal to H square. So by using this, if you have this data that is 5, 3 and 4, we can say that by just putting this value over here and it actually satisfying Pythagoras theorem, then we can say that this triangle this triangle is actually forming a right angle triangle. What I just say, that by looking at the data only, we don't need to draw this diagram, or we can simply tell that this type of data is actually telling that the type of triangle that it forms, it would be a right angle triangle. So that is the significance of Pythagoras theorem. Pythagoras theorem is actually being used only in right angle triangle. So that means by any sort of data, 3, 4, 5, that is the first data that we have used, and any sort of data whatsoever it is, let's say 12, 5 and 13. At this case also, 12 square is 144, 5 square is 25, and 144 plus 25 is nothing but 169. So that is 169 is nothing but 13 square. So 12, 5 and 13, this type of sides are actually telling that is the figure will be a right angle triangle. Or you can say that there is one more term that we just use for Pythagoras theorem, that is called Pythagorean triplet. That is extra knowledge. Pythagorean triplet. Pythagorean triplet means what? Which actually satisfying Pythagoras theorem and nothing else, right? So one more example that I have given to you, that is 12, 5 and 13. This is one more example which actually satisfying Pythagoras theorem. So we can say that this is called as Pythagorean triplet. So that is the significance of Pythagoras theorem. So that means if you have base and perpendicular, that base or perpendicular, then we can able to find out hypotenuse by using Pythagoras theorem, or some more or less. If you have hypotenuse and base, then we can find out perpendicular, right? If something is missing, then we can replace it by using x and simply find out the answer. So that is the significance of Pythagoras theorem, and I hope after watching this particular video, the concept of parallelism and as well as the concept of Pythagoras theorem is much more clear to you. If you found something doubt related to Pythagoras theorem or parallelism, then make sure you just contact me directly. And that's all for today's video. I hope you just do much more practice related to Pythagoras theorem, and later on I will do some questions as well, right? No problem. All right, so that's all for today's video. Thank you and have a nice day.